Welcome to installment 1 of Grade 12 Financial Maths Snag List. It's called a snag list because it is pitched at everyone who has already done an entire chapter of financial maths. These are the snags that students have addressed with me where they are explaining that the way the question is being phrased or what is being asked of them is not entirely clear to them. And so this is addressing all of the issues that will come towards the end of the section where you've got to do things like choose a formula or handle the confusing ways in which words are used. And I want to put that disclaimer up front. I personally find this topic quite frustrating because I find words to be sometimes vague and the semantics can get in the way. You can have one word different in a question and it means you've got to do it differently. So I think that that's what trips a lot of people up. And so I'm going to deal with those as we go. The things I've highlighted at the top of this page is just explaining how these videos will work. So calculating n has come up a lot in the queries that students have sent me. And there's two ways of talking about that. The semantics are already a problem. The first one is to know how many payments you need to use in an FV or a PV formula. And the other one is to actually calculate n using logs. So I've covered those in a few different ways throughout these videos. So it's not going to be covered specifically as in this is the way you always calculate the number of payments because again it varies per question. So I've just dealt with it in each question. The other thing I'm going to deal with in as many questions where it is relevant is to answer the question as to whether to use the PV or the FV formula. And you can see I've already done that in the first one. And there it is, and I've put that idea of PV or FV into quite a few questions that follow. All right, I'm going to start with the first one. So here we are not given a compounding period, but we are told how often installments are made. And that can be confusing because you are used to being given all the information. The irony is you are actually given the compounding period by being given the installment period. They will always be the same. I think that's worth writing down. Your compounding period will be equal to the period of the installments. You might have noticed by now that most of the time this is monthly because in the world we live in we all get paid monthly, or we definitely do in South Africa. So we tend to have monthly everything. But I will address one that is quarterly in these videos just so that we've got an idea of that also being an option. Alright, so I'm going to do an example like this. Bob invests money over 10 years, so we're given the time period, at an interest rate of 6.7%. His quarterly installments starting immediately. That is also something that bothers a lot of people. So I'm addressing more than one issue in this question. Those are 5,500 Rand. Quarterly installments. So here is the example where I'm immediately dealing with something that's not doing monthly installments. How much can he withdraw in 10 years' time? So addressing the issue, which is how often do we need to compound the interest, it'll be the same as the way that the installments are paid. So because he's doing quarterly installments, we're going to then have quarterly compounds of the interest as well. Okay, they'll be exactly the same. So that means that when we work out our I here, when we sub that in, that's going to be something that goes over 4. Right, and then the next thing is to deal with the fact that this is starting immediately. Okay, so what does that mean? That means that Bob is now going to do an investment and he is going to put a payment in at the first place, which is T0, and then also at the last place, which is what? It's 10 years. We're doing it every quarter, so it's going to be, we can look at it like this. We can say it's going to be the 4 quarters per year times the 10 years. Okay, so that's going to be 40 quarters, right? Let me just write that down. 40 quarters. But that would work if he was going to pay at the end of the month, and he doesn't do that. He starts immediately. So there's an extra T0, and he's also paying T40. So if he was paying from T1 to T40, there would be 40 payments, but he's not. He's paying from T0 to T40, so there's 41 payments. Some people like to use a timeline for that. I find it easier in this case to just add on the extra one. The next question I'd like to address is this idea of PV or FV. Now I know it's completely obvious because I've gone and put the FV formula over there, and you also might find it really obvious because he's investing money. And so the normal way of looking at this is to say PV is a loan and FV is an investment. That's a little oversimplified. So what I want you to look at is, where is the lump sum? Am I putting money into a situation where I'm going to have a lot of money now? Because if I do that, I need to pay it off, and then it's a loan, and mostly it's a loan. There are other versions, and I will deal with that in my last question. Or is the big money, the lump sum, is that in the future? Am I saving a whole lot of little installments, and then in the future I'm going to have a lot of money? Or do I have all of that lot of money in the present, and then the installments are going towards the future? So where is the big money? Where is the lump sum? And for this question, he's investing money, he's doing quarterly installments, and he's doing 5,500 Rand per quarter, and then he's going to withdraw a huge amount of money in 10 years' time. So the lump sum is in the future, and that's why I'm going to use the future value formula. Okay, so now I'm going to sub everything into the formula, and I'm going to put in my monthly payment. Then here for the interest, I'm reminding you that because the payments are quarterly, the interest is quarterly. We were dealing with 6.7%, so reminding you that is something we need to make as a decimal. Okay, and it's over 4 because there's 4 compounds per year. And then I need to remember that what's happening up here by the N is I'm looking at my number of installments, or my number of payments, and we got there 41. Okay, I'm going to sub in everything else. And I'd like to remind you here that the substitution gets marks, and secondly that the typing into calculator can be full of errors. That you just missed one thing, it's slightly out, it's very out. It's definitely worthwhile typing in these things twice. Okay, which I've done to prepare for this video. Right, so my answer here is going to be 320,469 and 37 cents. I recommend you pause the video here and you go and type it in yourself and make sure that you're getting the same answer. My next question is actually a grade 11 question, but it's come up so many times in this section now that I just want to deal with it. And I also remember it was like it was unfinished business in grade 11 anyway for a lot of people. So you are told to convert a nominal rate to an effective rate. Okay, I'm going to pause there for a second. You are not given the formula for converting to an effective rate on the formula sheet in your final paper 1. Okay, this is the only formula that you have to learn off by heart. It does not appear on the final paper formula sheet. So that's the first thing. We've got to know it off by heart. I put it down here, but we've got to know. The second thing is, when you are told to then use the effective rate in the next part of the question, a lot of people go and compound it again. But when you've converted to the effective rate, you have converted to an annual rate. So that's why I've even put that wording in this question here, that you're going to convert to an annual effective rate. Okay, so what you do is you convert to effective, okay, and then you need to use the effective rate as an annual rate. And do you remember that back from grade 10 stuff, grade 11 stuff? You were then just going to go and put it into the normal compound interest formula where there was no compounding. Okay, so annual means no compounding. Well, you are compounding, but you're compounding once per year. So no add-on compounding like what we're used to doing. I'm going to work through this question so that we have a bit of practice, and then I'm going to use the effective amount in a calculation that follows. Okay, so first thing is to sub in all the numbers. Then I'd like to offer a way of doing this that I've noticed a lot of students prefer, which is writing out long numbers. You really don't have to, but some people really like to then go and put that into their calculator, get it out, and do it step by step. So I'm going to do it. You can just check your answer at the end if you like. If I type that in, I get 1,195618171, really long. Okay, and then what I'm going to do now is scratch that and just go -1. Okay, which means my effective rate as a decimal, this is the only other place where people lose a mark. I've now got a -1, and as a decimal I now have 0,195, all these numbers that I had there. And what you need to do at the end of these calculations is you've got to convert to a percentage. Okay, so I've got to get it into percentage, which is going to be, rounding off correctly, 19.56%. Now, the last part is to say, does that look about right? Should the effective rate be a little higher than the nominal rate? And the answer is yes. Not a whole lot higher, but something higher. It was 18%, it was really high anyway. So it should be quite a substantial amount higher, like a whole percent or more, and it is. It's quite close to 20% actually. So it feels right. And I think that's also important with finance, that wherever possible, you try to work on your gut feeling for what the answers should be. Addressing the next part of the question, it said, then use the effective rate. So you have to use it as an annual rate to calculate the amount of time, so I'm calculating in, that it would take a lump sum of money to triple at this rate. So I'm going to be using logs because I'm calculating in. So again, I've embedded a different skill, an extra skill into this question type. Okay, so what I'm going to do now is I'm going to look at what it means to triple. Okay, a lot of you will realize all I'm going to do is just say 3 = 1, but using a method that's perhaps a little easier to understand for everyone, what I can do is say, well, I started off with x and I'm going to end up with 3x. So here I'm going to say, well, the 3x is my a value, the x is my p value, and I'm going to put it into normal compound interest. I also think that that causes issues because we really struggle with now knowing when do I just use a really easy formula that I've done before, because I've got so many other ones, so many hectic ones. Okay, so I'm going to use the rate as it was, but now in a decimal form, and what I don't know, my unknown, is the n. Okay, obviously my x's will now drop, so I'm just going to say 3 equals this whole thing. And again, I'm going to use a method that some people prefer, which is to just add those all up together inside, because they can be added. And now I have something that looks like a log equation. It can really easily be solved. Okay, so I know that my exponent becomes the subject of the formula in a log equation, and then I have the base as the base. So the 1,1956 was the base over there, so it's the base in the log as well, and then that is log 3 to that base. Okay, type that into your calculator and you're going to get n equals a very long number, 6,149,586,659. And I'm going to do I'm going to address one further issue here, and that is, okay, it's obviously 6 years, right? But what if I want to convert to months? Okay, so they don't always ask you to do that, but if they do, this is how you would. You would take the decimal amount and you would times by 12. Okay, so that's the step. is to convert to months, you will take the decimal times by 12. So literally on your calculator with your answer now, you're going to subtract 6, and then you're going to take 0,149, etc., the whole long thing, and you're going to times it by 12. Okay, when you do that, you're going to get 6 years and 1,79 months. And say they asked you to round off to the nearest month, your answer would then be 6 years and 2 months.